Hello all, thanks for checking out Skillseed Freedom to Learning YouTube channel. Now let us start basic of electrical basics of electrical system. What is electricity? Electricity is the movement of charge which is considered by convention to be from positive to negative. No matter how the charge is created chemically, like means the example is batteries, or physically, friction from socks and carpet. The movement of the discharge is electricity. Now, next is understanding current. This flow of electrical charge is referred to as electrical current. There are two types of current: direct current DC and alternating current AC. DC is current that flows in one direction with a constant voltage polarity, while AC alternating current is a current that changes direction periodically along with its voltage polarity. Thomas Edison and Volta were pioneers in DC current and wrote much electricity's history. But as societies grow, the use of DC over long transmission distance become too efficient. Nikola Tesla changed all that with invention of alternating current electrical system. With AC it is possible to produce the high voltages needed for long transmissions. Therefore, today's most portable devices use DC direct current power while power plant produce AC alternating current. Means what? Nowadays use of DC is huge instead of AC. Now let us see Ohm's law. The most fundamental law in electricity is Ohm's law, or V is equal to IR. It is the equation of the Ohm's law. The V is for voltage, which means the potential difference between two charges. In other words, it is a measurement of the work required to move a unit charge between 2 points. In the field, you might hear the terms common ground, which refers to each device in a system using the same 0 point reference, means ground, to ensure the same potential difference or voltage is applied throughout the system. The next component of Ohm's law is current, the unit of which are ampere. In the formula, current is represented by the very logical choice of the letter I. Current is the measurement of flow of charge in a circuit. This leaves us with the letter R, which represents resistance. Electrical resistance measured in ohms is the measure of amount of current repulsion in a circuit. Simply resist current flow. When electrons flow against the position offered by resistance in the circuit, friction occurs and heat is produced. The most common application for resistance in a circuit is the light bulb. The light bulb introduces enough resistance in a circuit to heat up the filament inside, causing light to be emitted. The heat is to be generated or emitted throughout the light or the bulb, which are having resistance filament. The material of that filament is tungsten. Next is series and parallel circuit. First we need to understand what is series and parallel circuit means. Series circuit are those which are connected in line with the power source. The current in series circuits is constant throughout, but the voltage may vary. Parallel circuits are those which branch off from the power supply. The total current supplies from the power sources is divided among each of the branches, but voltage is common throughout the circuit. If one goes out, it causes an open circuit that at point. No current will flow to the other light because of the open circuit path. A lot of new light strands are wired in parallel. Therefore, in one light goes out, then only that branch of the circuit will be out. The open will be isolated to that branch and current will continue to the other light in the strand. I will share its diagram also. Now next is power equation. One of Last equation that is useful to remember is power equation. P is equal to IE into P is for power measured in watts, I is for current, and E is for voltage. This equation can be combined with Ohm's law to solve for values that are unknown. For example, in Ohm's law we know that I is equal to E upon R. So combined with the power equation, P is equal to I into E. Now we get P is equal to E into E upon R, or simply P is equal to E square divided by R. Also from Ohm's law we know that E is equal to I into R. So combine this path with P is equal to I E, and we get P is equal to I square R, the final equation of power. Using the previous parallel example, we can find the power consumed by the circuit. From the equation we can find the total load consumption, voltage, current, and power distribution in DC circuit. Now next topic is basics AC circuit. Unlike DC current, AC voltage or current changes its direction periodically as it increases from 0 to maximum and decreases back to 0, then negatively continue to maximum and then again back to 0. The frequency of this cycle is about 50 cycle, means 50 Hz per second in India. For high power applications, AC is more predominant and efficient source than DC. The power is not a simple product of voltage and current as in DC, but it depends on the circuit components. Let's see circuit. A voltage source is connected to a resistance. The waveform start from 0 in alternating periodically, means half positive and half negative with the help of time. Next is AC circuit with inductors. Inductors is a coil. Inductors oppose the change in the current through them, not like the resistors that opposes the flow of current. This means when the current is increased, the induced voltage tries to oppose this change of the current by dropping the voltage. The voltage drop across an inductor is proportional to the rate of change in the current. Therefore, when the current is at its maximum peak means no rate of change in shape. The instantaneous voltage at that instant is 0, and reverse happens when the current peaks at 0. Peaks at 0 means maximum change of its slope. So there is no net power dissipation in the inductor in AC circuit. The instantaneous power of the inductor in this circuit is entirely different from the DC circuit where it is in same phase, but in this circuit it is 90 degrees apart, so the power is negative. At times as shown, negative power means the power released back to the circuit in the cycle. This position of current change is called as reactance and it depends on the frequency of the operating circuit. Next is AC circuit with capacitor. A capacitor opposes a change in the voltage which is dissimilar to an inductor that opposes a change in the current. By supplying or drawing current, this type of position takes place, and this current is proportional to the rate of change of voltage across the capacitor. The simple diagram is a source means a voltage supply is connected to a capacitor. In this type of circuit, the current through the capacitor is result of the change in the voltage in the circuit. Therefore, the instantaneous current is 0 when the voltage is at its peak value. Peak value means no change of voltage slope, and it is maximum when the voltage is at 0. So the power also alternates in positive and negative cycle. This means it does not dissipate the energy but just absorb and release the power. As we know the basics of capacitors, AC circuit behavior can also be analyzed by combining the above circuit like RL, RC, RLC, means by combining the parameters like inductor, capacitor, and resistance. Circuits in series as well as in parallel combination, and also the equation and formula of the above circuits are exempted in this article. So we will study later. We will posting new audio videos on electrical engineering courses and workshops online and personal weekly. Please subscribe for more on YouTube, Facebook, Instagram. Thanks and happy learning skill seed.